Today's learning goal is I can use properties of exponents to simplify and evaluate power expressions. We're going to be working with this learning goal for a couple of days. Okay. Today what we're going to be doing is we're going to be learning specifically about the product of powers property. Okay. And so product means multiplication, powers also means repeated multiplication. And so we're going to be learning about how we can simplify some expressions that have multiplication between two powers. So, for example, 7 to the 4th times 5 to the 4th. Now, if we wanted to write that as repeated multiplication, we know that 7 to the 4th is 7 times 7 times 7 times 7. Okay? And that's being multiplied by 7 times 7 times 7 times 7 times 7, 5 sevens. So overall, that's 9 sevens right here. Okay, so that's 7 factors. Remember, factors are numbers that are being multiplied together. Okay, numbers that are being multiplied together. Numbers being multiplied together. So here we can see that there are 9 of them. Okay. There are 9 sevens right here, so therefore this can also be written as 7 to the 9th. Here we have a negative 4 to the 2nd and negative 4 to the 3rd. Okay, just to give you guys some definitions, the base is the number that's being multiplied together, so this is called the base. So here the base is negative 4, and the exponent is the small number right here. This is called the exponent. Okay, so it is, in this case, negative 4 is the base, 2 is the exponent. So that's negative 4 times negative 4, and then the next part, if it'll go over, is negative 4 to the 3rd, so that's, again, a base of negative 4 and exponent of 3, so that's negative 4 times negative 4 times negative 4. Okay. Here we have negative 4 times negative 4 times negative 4 times negative 4 times negative 4, so we have 5 negative 4s being multiplied together. There's 5 factors, so therefore this is negative 4 to the 5th. Okay. Next, x to the 1st. Okay. So there's only one x, and then x to the 5th. So there are 5 x's right here. Okay. So that's x times x times x times x times x times x. Remember that there's multiplication signs in the middle of these x's that we don't see. So overall there are 6 x's being multiplied together, so therefore it's x to the 6th. So the next question is, what is the pattern between the exponents and the original expression and the exponents in the simplified expression? Okay? So I want you to write down what you observe about these two things. So what is the relationship between, for example, 7 to the 4th times 7 to the 5th in our simplified expression 7 to the 9th? What you should have figured out is that the exponents, when you add them together, get you the simplified exponent. So the simplified expression's exponent is the sum of the two exponents in the original expression. So, for example, if we had 5 to the 3rd times 5 to the 5th, that's the same thing as simplified 5 to the 8th. Okay, so here 5 to the 3rd, 5 times 5 to the 8th, we do 3 plus, we do 3 plus 5, which gets us 5 to the 8th over here. Okay, so if let a be a real number and m and n be positive integers, okay, to multiply powers having the same base, so notice how they have to have the same base. We have 5 to the 6th, 5 to the 3rd, both of them have 5 as a base. You simply add the exponents. So here 5 to the 6th times 5 to the 3rd is 5 to the 6th plus 3, which is the same thing as 5 to the 9th. Here, if we just want to use this with algebra, so we can write a general rule for it, a to the m times a to the n equals a to the m plus n. So here, we're going to do 2 to the 2nd times 2 to the 3rd, and we're going to do it by the long way first. And what I mean by that is expanding it out. And so 2 to the second is 2 times 2, and then we have 2 to the third, which is 2 times 2 times 2, which means we have 5 2s, so we get 2 times 2 times 2 times 2 times 2. The shortcut way is simply adding these 2 and 3 together. So we have 2 to the 2 plus 3, and our final answer both ways is 2 to the 5th. Go ahead and try this part out on your own. What you should have gotten is 9 W's plus 2 W's, so we have 11 W's right here. Or we can do a shortcut way, W to the 9 plus 2, which is all the same, W to the 11th. Okay. Notice that these all have the same bases. This is a 2, this is a 2, this is a W, this is a W. You cannot do this with different bases. Okay. You can only do it with the same base. So here, we have 4 to the 4th times 4. Now 4 by itself is the same thing as 4 to the 1, okay, because that's only one 4 being multiplied by itself. So it's 4 to the 1. This 4 right here is the same thing as 4 to the 1. Okay. And then we can add the exponents, so it's going to be 4 plus 1. So 4 to the 4 plus 1, which gets us 4 to the 5th. Here we have, again, negative 6 times negative 6 to the 6th. This negative 6 is the same thing as negative 6 to the 1. So this is going to be negative 6 to the 1 plus 6, which gets us negative 6 to the 7th. Okay. Mixed practice, we are going to work on this in class. Notice how these questions right here have multiple bases. Okay. When there's multiple bases, you cannot add the ones that have different bases. Okay, so I could only add these two, this a to the third and a to the second here. Okay, and then in class we will talk about what to do when we have a number in front of the variables.